Hello, everybody. My name is Yerkebulan. I am a doctoral student at the Almaty University of Power Engineering and Communications, Almaty, Kazakhstan. The topic of my report, study of strange and thermal characteristics of university nanosatellites. Satellite technologies are of global importance in the social and economic development of the entire state as a whole, and also allow us to raise the information and the space support systems of various countries to a high level. Within the framework of small satellites, we should mention nanosatellites developed at universities for educational purposes. The main objectives of these initiatives are first, engage students in complex teamwork aimed at designing and developing and producing a complex product, thus training students' ability to solve real-world problems. Second, foreign orbit testing of components and the materials intended for ground use in order to reduce the cost of future space missions. Third, demonstrated the feasibility of innovative missions and the system concepts. The resistance of the materials and the equipment elements used in their creation to the effects of the surrounding space environment plays a crucial role in ensuring the long-term trouble-free operation of nanosatellites. According to the available expert estimates, more than half of the spacecraft failures and the failures are caused by the adverse impact of the space environment. The strength of the nanosatellite's body provides additional requirements for the structural materials used in the manufacture of the body. Namely, first, high vibration and impact strength. Second, resistance to corrosion and abrasive wear. And the third, higher crack resistance at sharp and abrasive temperature change. Figure 1 and 2 shows the typical strain curves of our different aluminum alloys in initial tensile test compared to low carbon steel, high strain steel, and the titanium alloy. The digital model is simplified in a two-stage. First stage, removal from the model of all elements that don't contribute to the strange characteristics of model. And the second stage, correction of interference of parts.
Dr. Nurgizat,
What?
but your presentation file is not flowing, is not running.
Not see my presentation?
We see your presentation's first slide, but it is not flowing.
Ah. And now?
It is not flowing. We don't see the next slide.
Just a moment.
Can you share your file again?
Okay. And now?
Now, okay, now it is running.
Ah, okay.
Okay, now.
Sorry.
It's okay.
To determine the first load in the body, the gravity force formula, Cu formula 1. And the next slide, as a result of this research on the analysis and the selection of the most suitable design material for the development of a nanosatellite model. Studies of strange characteristics of aluminum alloys of various grades. And a three-dimensional model of a nanosatellite was constructed in SolidWorks. In statistical calculations, the displacement of the frame is equal to 1.225 millimeters. And the main method of calculation of the thermal regime is the graphic analytical method. The task of the calculating the thermal regime of an satellite, as a rule, is to determine the temperature and the temperature overheating of the components. And they obtain the calculation formulas for the design the thermal models. We take the following data. First, the altitude of the nanosatellite, high 160 kilometers. And second, the nanosatellite's orbit is near Earth. Third, the effect of various thermal loads on the nanosatellites during flight. Two cases of operation of the thermal regime were considered. First, when the nanosatellite is located in the shadow segments, and the second, nanosatellite is located on the solar side of the orbit. The calculation, the calculation of thermal loads is performed for a three-dimensional model of nanosatellites. The simulation was performed for several orbits in orbit. The thermal state of the nanosatellite was calculated using the simulation SolidWorks environment. And the finite element model of the nanosatellite is built automatically. And the load is applied consistently across all the faces and the components of the nanosatellites. Show the figure 10 and 11, the change in the body of nanosatellites in the shadow and the outside shadow segments of the orbit. As a result, according to conducted research, the most suitable thermal regime for the nanosatellite in different parts of the orbit was selected. And aluminum alloy is well suited for assembling the nanosatellite frame. So in conclusion, this study will simplify the launch of small spacecraft into space due to the insignificant requirements for the creation of a nanosatellite design. The analysis of criteria for assessing the strength of nanosatellite structural elements made of composite materials in carried out. The strength reserves determine the maximum displacement of the structural elements found. In the SolidWorks software environment, and effective solid-state finite element model of a nanosatellite was developed, on the basis of which the stress-strain state of the nanosatellite was analyzed. And this study is intended to educate students in the development of nanosatellite. Thank you for attention.